Okay, for this one, it says the population of deer in a forest is currently 800 individuals. Scientists predict that this population will grow at a rate of 20%. So that's kind of important. So this is growth and the rate of 20%. So remember that 20% is 20 over 100, or as a decimal, it's 0.20, or really you could just say 0.2. Based on the prediction, how many years will it take for the population to double? So here's an interesting thing. For the population to double, this is the initial population, and this is the final population, right? But we want the final population to be 2 times the initial population. Do I know what the initial population is? No. So I could rewrite this equation as 2 times the initial is equal to the initial times 1 plus 0.2 raised to the t. And that's what they were asking us, is t represents the number of years, and they want to know how many years. So how many years until the population doubles? And then they define that r represents the growth rate, blah, 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 using this formula. So the first thing I notice is that if I divide both sides of the equation by p naught, or p sub 0, then this cancels with this, and this cancels with this, so I'm left with 2 is equal to, now we're going to combine these terms inside the parentheses, 1.2 raised to the t. Now, I could plug this into, remember, this could be a log function, and the log function of this, right, so now I've got it in an exponential form, and now I can rewrite it as a log function. So it's the log of the base, right? So log of the base 1.2, right? And then m is what it equals. So this would be equals 2, and then we got to figure out what t is. So that's one way to do it, right? So if I plug this in a calculator, and remember, we could go to Mr. Adams' website. I have that one calculator embedded there in my website, which is taking forever to load. And when we take the log base something of something, we're going to get a number value. It doesn't look like a number, but it's really a number value. So that's one thing I want you guys to remember. If I take log base something of something, that has a numerical value. So I'm going to put the log base 1.2 of, what was it? 2. And then I hit enter. Well, I hit enter, but the computers are going really slow today. And it's approximately 3.8. Now, so it's approximately, t is approximately 3.8. So that just means that it would take 3.8 years. In other words, 2 occurs, or we get pretty close to 2 when I take 1.2 and I raise it to 3.8. So we could verify that too on a calculator. It'll be close, 1.2 raised to the 3.8, but it won't be exactly 2, but it'll be close. Oh, how come that didn't? Oh, there it is, right there. See that? It's 1.99999, but that's because we approximated it. But that's one way to solve the problem. Okay.